You know that feeling, right? The steady tick of the clock, the march from yesterday through today and on to tomorrow. It feels like the most basic thing in our lives, but what if that whole feeling, that flow of time is just an illusion? Okay, let's get into it, because modern physics is wrestling with a huge mystery, right at the heart of what reality even is.
And look, this isn't just some late-night philosophical question or something you'd see in a sci-fi movie. No, this is one of the biggest problems physicists are actively trying to solve right now. It's wild, because the closer they look at what time really is, the more it just seems to disappear. It's making them ask, is our entire experience of time just some kind of cosmic trick?
So, how do we even begin to solve a mystery this big? Well, like any good detective, we have to look at the clues. And what's so fascinating is that physics gives us three, and they're totally different, even conflicting clues about what time is. It's like we've got three witnesses to a crime, and, you guessed it, each one is telling a completely different story.
Okay, so our first clue. This is the one we're all pretty familiar with. It's what scientists call coordinate time. The easiest way to think about it is like a number on a ruler. It's that little t they plug into equations. You know, whether you're trying to figure out where a tennis ball is going to land or how fast an atom will decay, time in this version is just a background measurement. It's a label. It doesn't actually do anything. It's just kind of there.
But then Einstein shows up and gives us our second clue, and this one is a lot weirder. According to his theories of relativity, time isn't just a label on a ruler. Nope, it's an actual physical dimension, just like length or width or height. He said it's woven together with space into this four-dimensional fabric he called space-time. And here's the really mind-bending part. In this picture, the past, the present, and the future, they all exist, right now, all at once.
All right, our third clue comes from a field called thermodynamics. And honestly, this one feels the most familiar to us. This is what we call the arrow of time. It's the simple idea that time only flows one way, forward. And why is that? Well, it's because the universe is constantly moving toward a state of more disorder, what scientists call entropy. Think about it. An ice cube in a warm drink will always melt. It's never going to unmelt itself, right? That's the irreversible march of time that we actually feel.
So, okay, let's pause for a second. We've got our three clues, but here's the real problem. They can't all be right. They totally contradict each other. So which one is it? Is time just a simple label? Is it a real physical dimension? Or is it this unstoppable, one-way arrow of disorder? This massive conflict, this is what physicists call the problems of physical time. And this is where the rabbit hole gets really deep.
Okay, now this is where our story takes a seriously sharp turn. Things get really, really strange when scientists try to build one single theory that explains, well, everything. For decades, they've been on this quest for a theory of everything. But when they tried to smash their two greatest theories together, they found something absolutely shocking. So here's the fundamental clash. You've got general relativity, the theory that describes huge things like planets and galaxies, and it treats time as a flexible physical dimension. But then you have quantum mechanics, the theory for tiny things like atoms and particles, and it treats time like our first clue, just a simple fixed background number. Think about that. The two most successful scientific theories ever created fundamentally disagree on what time even is.
So back in 1967, a couple of physicists, John Wheeler and Bryce DeWitt, they decided to just go for it. They said, let's try to write down one single equation that describes the quantum state of the entire universe. I mean, the whole shebang, from the tiniest particle to the biggest galaxy. And what they discovered, well, nobody saw it coming.
When they wrote down their master equation for all of reality, the Wheeler DeWitt equation, the letter t, the variable for time, it just wasn't there. It completely vanished from the mathematics. The most fundamental description of our universe that we have suggests that at its very core, reality is timeless. There's no past, no present, no future. Everything just is.
Okay, so wait a minute. If the universe is fundamentally timeless, then why do we feel time passing so strongly? I mean, we all just lived through yesterday, right? For decades, this was a huge, huge puzzle. But a new clue has popped up from one of the weirdest parts of quantum mechanics, a phenomenon that might finally explain how time emerges from a reality where time doesn't exist. And that phenomenon is called quantum entanglement. You've probably heard of it. It's this wild idea where two or more particles become so deeply connected that they basically act as a single thing, even if they're on opposite sides of the universe. Whatever happens to one instantly affects the other. And here's the kicker. We're now realizing that entanglement isn't just some weird, spooky party trick. It might be one of the most fundamental things happening in the cosmos all the time.
So, how on earth does this create time? Well, back in the 80s, two physicists named Don Page and William Wooters came up with this incredible idea. Try to picture this. The whole timeless universe is made of two entangled parts. Let's call one part the clock, and the other part everything else. And that everything else includes you and me. Now, because we're inside the system and entangled with the clock, when we look at the clock and see it says, say, 3 p.m., that act of looking forces our reality, the everything else part, to instantly snap into the version of itself that matches 3 p.m.
So what does that actually mean? It means that if you could somehow step outside the entire universe and look at it, you'd see all of time existing at once, a static, timeless block. There's no past, no future, no flow. Our experience of a timeline, of a now that's constantly moving forward, isn't fundamental. It's what scientists call an emergent property. It's basically an illusion created from the inside, all because we're entangled with the rest of the universe.
But you know how these things go. Solving one massive mystery just seems to open up another one that's even stranger. Because if time is just an illusion born from quantum mechanics, that has some really profound and frankly weird implications for one of the most basic rules we live by: cause and effect. I mean, we all get this, right? It's baked into how we see the world. You flip a switch, then the light turns on. Cause comes before effect. It feels like an absolute, fundamental law of reality. But when you start mixing quantum mechanics and relativity together, that simple unbreakable rule starts to look, well, kind of breakable.
See, in the quantum world, you have this thing called superposition, which is just a fancy way of saying something can be in a fuzzy state of multiple possibilities at once. And it turns out the order of events can be in a superposition too. So you could literally have a situation where the statement event A causes event B and the statement event B causes event A are both true at the same time. It's a quantum blur. The causal order isn't actually fixed until someone or something measures it.
And this leads to probably the most mind-bending idea we've talked about yet, something called retrocausality. This is the genuine possibility that an action you take in the future could somehow reach back in time and influence something that happened in the past. It means that arrow of cause and effect we thought was so straight might not be so straight after all.
Which leaves us with one final and kind of profound question to chew on. We started this whole thing by asking if time is an illusion, but we've ended up in a place where we're questioning causality itself. So if the future isn't just unwritten, but can actually change what's already happened, then is anything ever really finished? Is the past just as much a realm of possibility as the future? Now that is a mystery that we are just beginning to understand.